Hey everybody, today we're going to solve the largest BST subtree problem on LeetCode. Problem description is we're given a binary tree. We need to find the largest subtree, which is a binary search tree, where largest means subtree with the largest number of nodes in it. Subtree must include all of its descendants. So here's what the example looks like. They give us this binary tree, and here is the largest binary search tree. 5 is greater than 1 in its left, 5 is less than 8 in its right. Okay, so the implementation for this, at least the way I've done it, is pretty straightforward. So here is the function LeetCode gives you. They want to know what the largest binary search tree subtree is from some root. And they want to know the integer. We return the integer, which is the number of nodes in that subtree. If the root is null, we just return 0. Null is a binary search tree, and it just has size 0. And then I've written this helper function isBinarySearchTree, which takes in the root, the minimum integer value, the maximum integer value. And if the root is itself a binary search tree, then we just return this other helper function I've written, the size of the root. Neither of those things is the case. The root is not a binary search tree. We can just return the maximum of the largest binary search tree in the left and the largest in the right. And here's what the size helper function looks like. It looks like it's really simple. It takes in the root is null, then tree has size 0. Else we just solve it recursively. We return 1 plus the size of the left plus the size of the right. And then down here, the function that's doing most of the work is binary search tree. It takes in a root and a minimum value and a maximum value. If the root is null, we can return true. Right, so null is a binary search tree. If the root's value is less than the minimum value or it's greater than the maximum value, then we return false. That means it's out of bounds. And then recursively we solve the left and right. So we return if the left is a binary search tree and the parameters here are the minimum value, and then the maximum value is the root's value minus 1. And then is binary search tree of the right, and the min value is now the root's value plus 1, and then the max value. And these values are because everything on the left has to be less than the root, everything on the right has to be greater than the root. So that works. Having a quick look at it here, pretty sure we can simplify this code just a little bit. Alright, yeah, so since we do that check first, we don't need to check that. So that makes the code a little shorter and cleaner, so here's what the final solution looks like. And again, all we do basically is just, here at the top function, if the root that we're given is a binary search tree, return the size. Else we just return the max of the largest in the left and the largest in the right. So pretty simple recursive tree problem.